Assalamualaikum warahmatullah. Very good morning, guys. So first of all, very sorry, apologize for the delay. So things seems like I cannot use my pad and link to the laptop. So I just proceed with the cam scanner version. So hopefully it can fulfill our discussion today. Okay, as you can see, and please take your pen and jot down or redraw whatever that I'm discussing today. So we are going to discuss on the synchronous machine and summarize all what we have learned so far with me on the synchronous machine. Okay, for synchronous machine we have two section or two group, which is generator and motor. We have learned through all generator type of machine, operation, performance, efficiency. Then we went over to motor discussion later to that. Okay, now I will try to wrap up with to combine and to compare between the two machine that we have discussed. So first of all, if you take a look on the synchronous machine, it's just the same construction per what you have learned in induction machine. It's just that your synchronous machine, the rotation of your shaft will be at exactly the same frequency or the speed of your rotating magnetic field. That's all. Synchronous. It will be in synchronous. Okay, first of all, when you have any scenario, please draw or sketch this single line diagram. See here? This single line diagram here. So please draw. I will share this one copy slide of this scan version to you all later inside the WhatsApp group. For time being, please follow through my discussion, and you can pause the slide or this video to sketch, and you can continue afterwards. Okay, draw this single line diagram for, let's say, generator is the left hand side. You will transfer the power to the grid, and to the grid into your utilities, which might be connected to any external load, a motor here. So this is just a simple single line diagram for transmission lines. So on the generator part, it might be connected in Y or delta. Same goes to your utility part. It might be connected in Y or delta. You draw, you sketch the three-phase diagram, and you write down all the equation involved. So for Y connection, your current, line current, and your phase current is at same value. See here, what goes out from phase will go to the line and go to your utilities. If it connected in delta, so V phase and V line are at the same terminal values or reference. But your current will be, you have to divide, or you have to times 3 for I line and from I phase. So you just sketch the related layout or scenario, then write down all the related what so-called equation on the sketch. Then when it goes down into three phase, let's say we take a look on your generator part first. So focus on generator parts. So you can see here, when it goes down into three phase from the system scenario, three phase, and go down into single phase equivalent circuit. So draw your equivalent circuit for your generator. Generator means that it converts from mechanical rotation of your shaft into electrical output current into your external load and external lines. Okay, you have V phase, V field to provide magnetic field to your rotor. Then you will rotate your shaft, and you have generator right hand side. You have your force, you have your magnetic field, so you shall have your current, and your current. Nampak kanan. and kanan. Okay, force you have, magnetic field you have, so the current will flow to the line. Okay, the line, right hand side. So you will have the current that flows into your VT. So you draw this single line equivalent circuit to label all the related parameters that required inside your diagram here, the arrow of your current. Then you can derive the equation. So the shaft rotate, it will generate EA. So EA will be generated. And so this is your positive, negative, and the current will flow out to your external line here, and will flow out. So that's why we have EA, which is your source, is equal to whatever drop across your RSIS, IARS, across your JXSIA, across your VT. That's why we have here VA is the amount which is induced into the circuit, and it dropped or depleted throughout your IARA, throughout your JXSIA, throughout your VT. So this is the equivalent equation derived from this circuit. And for VF, for this part, the same lah. And IF equal to VF over IF. VF over IF. Same like your machine for your DC machine. And I equal to V over I. V over R. VF over RF. Okay, the same. Or you can arrange later lah into this arrangement later lah. Okay. So this is your single phase equivalent circuit for your generator. Then from this equation, and you reduce just now from 3 phase into equivalent single phase, then it will reduce into your single phase phasor diagram. So the single phase phasor diagram is generated from this single phase equation. So actually, how you generate single phase phasor from the equation? So you rearrange into this kind of equation step. Because why? EA is amount of all the components here. And so you can see EA is the amount of V phase plus VT here plus IARA, see, IARA plus JXSIA plus JXSIA. Means that the arrow will be EA is amount of V phase plus IARA, sorry, plus JXSIA. And so this is your result of your EA. And amount of this one plus this one plus this one. Actually, how to draw this? And so the equation is equivalent. And equivalent. What? EA is equal to VT plus IARA plus JXSIA. So you generate this kind of diagram. And this one is for, let's say your IA is at leading, your theta at leading. So the arrow will be like this. Let's say if your theta is at lagging, so how would it be? Lagging. And if it's lag, so the same. See here, if your angle is lagging, and so lagging, V phase is our reference. V phase will be stick at 0, and so lagging. So IARA will be same angle of IA times RA, which is very small. So that's why you can see that the magnitude is very small, or can be neglected. Let's say this is the length of your magnitude plus your JXSIA and VT or V phase plus IARA plus JXSIA is equal to the resultant of your EA. You see now. So this one plus this one plus this one equal to this one. And EA equal to BT plus IARA plus JXSIA. And most of the time, your generator will have a very, very low RA or negligible. So that's why the length of your IARA is very little. And it continues with your JXSIA here. So your EA will be here. And you cannot see anymore this part because it was negligible. And the what's so called your magnitude of IARA is very, very low. And very, very low. This one I just exaggerate such that you are able to have a guide how to sketch your JXSIA punya magnitude and angle, because the angle of your IARA is the same angle of your IA here. The angle of your JXSIA is 90 degree compared to your angle of your IARA. So this is for your guideline. Okay, this is how your phasor diagram generated for generator. And you can compare back in terms of their magnitude. EA is equal to VT plus IRA plus JXSIA. EA is equal to VT or V phase IRA plus JXSIA. So this is for generator. Direct, forward, direct to the point, positive, 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 and positive, 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 and direct to the point. But for motor, and so drawing start with V phase, V phase as our reference, then I phase as our reference, then only you plus IRA plus JXIA, you will produce your EA. Simple, You can repeat or replay my video to have to digest what I'm trying to deliver. So that's for generator. What about for motor? Motor quite tricky, but as long as you have reference here, you should be able to you have this single line diagram, you have this equation written down somewhere, you are able to distinguish or able to draw correctly. So just now for generator, now for for motor. So for motor, the flow of your IF the same. It will deliver current to produce magnetic field. But now the flow is inwards. The current delivered to your circuit, then you will produce rotating shaft. This is motor. Motor means that from electrical into mechanical. That's why you have here current flows into your circuit. Okay. So the equation will be the source of your current, source of your voltage here is the highest part. So VT is your source. You will drop across your IARA, drop across your EA, drop across your EA, IARA, JXSIA. Or you can rewrite such that you are able to draw your phasor diagram easily with this one. VT equal to EA plus JXSIA plus IARA. So how to start draw your phasor diagram? You just sketch your V phase and your angle of your current. So this is your theta. Your current will be IA magnitude with the angle of theta. Meanwhile, your voltage magnitude of V phase, angle at 0. Angle at 0. Start with that drawing, phasor diagram. Then what you have to do? Okay, we'll continue with the slide.